Okay, this topic that we're going to look at today is difference of squares, but in the formal sense or a different formal sense. So we've already looked at difference of squares using decomposition, and that is the type of question that you've seen before where it looks like this. X squared minus, I don't know, some number, some other thing. Let's say 4. X squared minus 4. It's a difference of squares, and we have rewritten that as, or when we do decomposition, we treat it like this, where there's no middle x term, and we do decomposition, but we have to account for this 0x in the middle, and it just slightly changes the way we get our decomposition numbers. However, many of you already know that there are a lot of different tricks to be able to factor quickly, but decomposition it's more foolproof, and it's a little bit safer because there's checks along the way that tell you whether or not you're still doing it correctly. Difference of squares also has shortcuts as well, but let's look at a different way to look at difference of squares. So difference of squares basically looks at subtraction. So we've got let's look at this picture where we've got two different squares, and well, a difference of squares means that we're taking one square and subtracting another. So let's take this little square, and we're going to say that it has a side length of, let's say, y. So that also means that this side length here is going to have a side length of y. If we look at the bigger square, we're going to have a side length of x, and similarly a side length of x along here. So when we get down to it, if we look at a difference of squares, right, we have the area of the large square minus the area of the smaller square. And this would be, well, the large square has an area of x squared. The area of the small square has an area of y squared. A difference of squares. Okay? Now, let's just take this picture again. So let's take our x and our y, our x square and our y square, and let's do something here where when we actually remove it, now I'm going to look at this shaded region and this shaded region. I think we can agree that once we remove the blue square, the thing that is left over is this L shape, or this upside down L shape. And the area of that would be the area of these two trapezoids. So I'm going to move those over here and redraw them. One of our trapezoids looks like that. Fair enough, right? And our other trapezoid, this one, I'm just going to kind of twist it around and line it up here. And there we go. I've got my two leftover pieces, but it's almost like I cut them out of paper and just twisted them around and fit them together. So let's look at the area of this. Well, before, we've agreed that this here had a length of y, and this here had a length of x. Well, this side here, this length, that's the same as this side length here. So this one I know is x, and I know that this one is x along here. I know that this side length here is equivalent to this side length here. And I know that this side length is going to be x, the total length of this entire side, minus y, this part here. So this side length here is x minus y. Fair enough. Now similarly, this part here, this side length, came from this bit here. And this bit here is y. So, building this picture, I could also say that the total area is equal to the length times the width of this rectangle. It's the length times the width of this rectangle, and the length of it is, well, x plus y, and the width of this rectangle is x minus y. Now, from these two pictures together, we've gotten an area of the white leftover part. We found it two different ways. One of them was taking the area of the big square, subtracting the area of the small square, and we've decided that the area of the white part is, from this picture, x squared minus y squared. I don't know why I put the brackets. Maybe I'll take them out. We agreed that that was x squared minus y squared. However, we've also found the area of this, the white part or the cutaway part. We found it another way, and the area that we got from that is the expression x plus y times x minus y. So, if we had done this by decomposition, we've actually gone from something that's in expanded form, right, things that are added together, to factored form. Lo and behold, here's the idea. Based on our picture, we can come up with a formal way to factor a difference of squares quickly. So, more formally, any value squared minus any other value squared can be factored very quickly as a plus b times a minus b, which is the result that we got down here. X plus y, x minus y, and we have our x squared minus y squared here. So in general, anything squared minus anything squared is equal to this format. Or another way, I guess, of rewriting this is to say a squared minus b squared. Now the nice thing about this is that if you can get it to kind of look like this, whatever's in these two brackets you can automatically just kind of cut and paste and put them there. Plus or minus, minus plus, order doesn't matter here. And there we go. That's a shortcut to factoring a difference of squares. If you can recognize questions that are difference of squares, they're a lot faster than trying to do it by decomposition. Now, one final note, it must be a difference of squares with a minus sign, okay, not a sum of squares. So this one, let's say x squared minus 4, I can sort of maybe rewrite or think of it as x, which is squared minus. Now instead of 4, I'm going to write it as 2 squared. Now if I can do this and I see a minus sign in the middle, I know that I can factor that equation or that expression like this. That's a lot different than having x squared plus 4. This would be a sum of squares, right? Two squares added together. This is not the same thing as x plus 2, x minus 2. And the plus sign is y. And we can check that by re-expanding, okay? So x squared minus 2x plus 2x minus 4. So this would give me x squared minus 2x plus 2x goes away and I'm left with 0x minus 4. These two things are not the same, so be careful when you have a sum of squares versus a difference of squares. This is okay. This, no, not good. Well, there you go. That's the shortcut to how to factor difference of squares, and we derived it by using the area model here, which is a pretty cool model to use. Area models are fun to use and can be really useful. All right, goodbye.